Alright, so we have this question, subsets 2. I have already done subsets 1, so uh, we do have the little back approach of it, like what has to be done in this question. So at the moment, it says given an integer array nums that may contain duplicates, return all possible subsets. The solution set must not contain duplicate subsets, return the solution in any order. So these questions are like the subsets one are more like based on pick and non-pick. So like we either pick the element or we not pick it. So like for example we have 1, so either we can pick it or we can not pick it. So when if we out of this array, if we consider 1, if the index is at 0, so if we pick it, our array will be 1. If we not pick it, it will be empty, and then the left one will be followed first. If we pick another element, it will be 1 comma 2. If we not pick, it will just be 1. Then the left recursion tree again follows. If we pick, it will be 1 comma 2 comma 2. If we don't pick, it will be 1 comma 2. And then the left one will follow again, but now we don't have any other elements to pick or not to pick, so it will stop right there. Come to this one wherein we can pick or we cannot pick. So that's how the recursive tree works for it. Backtrack, and obviously like if the left recursion tree is working first, then eventually the right recursion tree has to work, so it will have to backtrack. So if the base became 1 comma 2 comma 2, it will have to go up, backtrack to the initial value which was 1 comma 2, and then the right recursion for that command will follow, that is 1 comma 2 comma 2 or 1 comma 2. So that's how this recursion works. And yeah, now what we can do is we can follow this approach, because this thing looks pretty same as subsets 1. We can follow this approach wherein we have a private void which returns nothing. We call it helper function. So basically it will have our int nums, yeah, it will have int I, which will be the index. It will have a list integer, and it will have list, a list within a list. So yeah, so this is what it will consist. We'll name this one as current and this final one as result. So initially what we will be doing is we will be playing around this list, this current list, adding or removing the elements from this list, and when we are done with it, we will be adding this current list to the result list. So yeah, that's the basic approach that we will be following. So what we can do at the moment is, for the recursive function we can have the base case. So here, as we followed the tree, when we realize that all the elements have been covered, we will have to stop. That is the point where we will have to stop and then add the current list to the result list. So if I greater than equal to nums dot length, yeah, if that's greater than or equal to nums dot length, then what we have is result dot add new array list current. So basically with this thing, with this command, and we can just do return, so it stops right there, nothing else has to be done, it returns. Base condition hits, it adds, and it stops. So yeah, Earlier with the subsets 1 question, the question that subset 1, what I was doing was I was adding result.add, and then I was here saying add current. That's it, not new array list current or something. I was just saying add current, so nothing else. It's just writing current in it, which isn't the right or the useful approach. Reason being that current initially is empty, so yeah, we need a copy of it, not the empty current, because then the moment the base condition hits, all it will be doing is adding an empty array list to the result. That's going to be out there returned, so every element will be empty, so it makes no sense. So getting out of the base condition, so what we can write now is now we have to talk about pick and not pick. So if we call helper and then we say nums I plus 1 current result, so base condition is not hit, so then we call helper again, and then what we do is in the same array we increment the index. And then obviously if we are incrementing the index, we'll have to take care of the backtracking case, because we went an index ahead, so we'll have to come back to get the right recursion tree as well. So backtracking, what we will be doing is we will be current dot remove current dot size -1. Yeah. Yep. And then the case of not picking the element. Wait, first of all we'll have to add the element 2. I forgot about that. So current dot add nums I. Yeah, we add, we increment, we add, and we increment, but we remove as well. So yeah, then not pick helper nums plus 1 current result. Yeah, so here what we can do is we can create this. Yeah, new array list. Yeah, and then we can have this copy pasting the above line. Yep. So what we can do according to the function is that we have two lists over there. We can call the function. The function will be filling the result one. Yeah, give it nums, give it 0, give it current, give it result. Yeah, and then we can return answer because it asks for return condition. My bad, result. So let's see what happens. Initially the code starts. We are having two lists. List of list. Helper is called nums array from the 0th index. yeah, 0th index. So what happens is I less than is I greater than equal to the length? Nope. So then we add it, we add 1, yeah, we add 1. So initially it's empty, yeah, initially it's empty. We add 1 to the current. Initially current is empty, we add 1 to the current, all right, and then what we do is we move ahead, we move an index ahead. So now we are at index 1, that is having element number 2 on it, but we backtrack at the empty one, and then our command hits this. Obviously we will backtrack because that's how recursion works. When the left tree is done, it backtracks to the main and then it follows the right one. So we backtrack to the initial one, which was empty. This helps in backtracking. It makes it as it was initially, that's empty, because we removed 1 in this case, and then it just moves ahead. So what we have is we have 1 and we have the empty one. So now what will happen is that obviously we will first see the left recursion call. So with 1, either it will add 2, which it will, yeah, so it will become 1 comma 2, and then we move ahead, but it comes back 1 comma 2, and that's how it goes, like simple, 1 comma 2. So yeah, so now then we keep adding, and then the recursive tree, that's how it follows. So yeah, I guess that's pretty much it with the question. Let's see. Okay, so wrong answer in first. Okay, still it works. Okay, so the output we are getting is 1 comma 2 comma 2, which is needed. 1 comma 2 is needed. 1 comma 2 is getting that again, not needed. 1 needed. 2 comma 2 needed. 2 needed. Then again getting 2 and getting the empty one. So 1 comma 2 and 2 are getting repeated. Let's try to understand the reason behind it, like why is that happening. Let's ask ChatGPT to build a recursive tree for us. Yeah, wait. Alright, so here we have the recursive tree. So we start at 0, we pick or we don't pick 1, yeah, 1 at 1. Now alright, so I'll tell you how the backtracking works. It's at 0, yeah. There is a reason why we have yep, there is a reason why we have this, yeah, current not remove thing with us. So the reason is that when we start, either we pick. So now when we are thinking, alright, we pick one. So in recursion, the left thing keeps on going. When it ends, the right recursion takes place. So when we pick, so now, yeah, we have one in the array. So now it will backtrack to this. So it removes the element, it removes the element, and then we don't pick. So yeah, same happens right here. So now we have two cases. So now left and right. So left and right in a recursive tree, there's a left and there is a right. But obviously the left one implements first. When it ends, that's the time right one starts to execute. So so if we pick 2 in this case, we get 1 comma 2, backtrack back to it, yeah, and then what we see is that we have 1. So we remove 2, now we have 1. So the basic recursive tree is like either we pick or we don't pick, and we pick or we don't pick, we pick, we don't pick. Simple. So the thing is that when we pick, in this case we get this, which is needed. When we don't pick, we get 1 comma 2. But when we pick with this case, we get this as well. So we need to figure out that how to get rid of this 2 and this 1 comma 2, because they are we do get duplicates. So yeah, that's the issue. We do get duplicates and we don't need them. Yeah. So to handle duplicate subsets, what we can do is either we can remove them. How can we remove them? We can and we have the if condition wherein it checks if that thing is already there or not. Or let it tell me. When you are deciding whether to pick an element, make sure not to get the same, because only first occurrence should be allowed to pick. Alright, if it's about the first occurrence, then can we have something like a count or something for it? Do we need a kind of hash, a map for it? Like we can have a count, like alright, this has been picked up, don't pick it again, something like that. I don't know, let's see. We can have something like continue, like we add if nums I same as nums plus 1, because we haven't been there. Continue, will this help? Really something. It's taking so long, so maybe it's time limit exceeded or something. I don't know why it's taking so long, but um, I just want to know what's the issue with the continue statement so that it's easy for me to figure that out. Yep. Outside the loop. I mean, where should I put it then? I mean, why this continue won't work? Like, is it some edge case? Will it make sense to use a for loop for a recursive question? Alright, so instead of that if thing, we'll have a while thing right here. So it's like, as it is the same thing, and x plus 1 is less than num sort length. Alright, makes sense. And then x equals to alright, and x plus plus. Okay. so it adds, and then it sees, it removes. Alright, so before skipping, so it adds, it moves ahead, it removes, backtracks. Yeah, it sees if the next one is same as that or not. If that's same, then it just skips it. Alright, it just doesn't consider it. If it's same, the index increases. So yeah, let's have a recursive tree for this. Alright, let's implement this. All we have to do is remove this, and before we backtrack, after we backtrack, we'll have a while loop that will see that if I plus 1 is less than nums dot length, and nums I is equal to nums I plus 1. Yeah, if I plus 1 is the nums dot length and nums I is equal to 1. If that's the case, index plus plus, and if that's not the case, don't pick it. So let's have a tree for ourselves. It's initially at 0, it adds 1 to it, it backtracks, it adds 2 to it. Yeah, and then it backtracks, checks if next element 1, nope, it adds nothing to it, it remains 0. Then with 1, so now the index has increased, I plus 1, we are at 2, it adds 2, 1 comma 2. Yeah, and then before not picking, it checks is next index like equal to true. It is, index increases. Yeah, and then we are at the last 2. Wait, I have a little confusion with the tree. Start index 0, pick 1. Alright, index 1, pick 2, index 2, pick 2, index 3, add. Alright, pick 1, index 1, don't pick, still at index 1. Yeah, pick 2, don't pick, skip both 2's at index 1, so it's like it's only 1. We are at index 3, it's the end, we add. Yeah, and then here pick 2, index matched, we add, don't pick, skip duplicates, index matched, we add, and then the don't pick thing is gonna follow up. We pick 2, alright, that's fair enough. So let's see if it submits. Yeah, my bad, it's I plus plus. Alright, so I'll have to work on it. I'll have to draw a recursive tree for the duplicate case. Alright, thing that had to be done. Arrays dot sort nums. How about that? Let's use this test case. How about that? Alright. Yep. What's the time complexity of it? It's a recursive thing, so yeah, I don't know. I did use sort, so it might be log in something. It's not. It's 2 and n. No way I could have figured that out. 2 power n into n. Its memory will be O of 1. Sorry, it's O of n. Alright, we created because array list. Alright. Such a stupid thing to say O of 1 when we are creating array lists. Anyways, I'll see you with the next question.